Okay. Um, Before we start the course, today we will have a quiz. But I think I will start the quiz around 2 p.m. Around 2 p.m. or maybe 2:10, maybe 2:10 p.m. So the first part, I will gonna start to ask you about the final exam schedule. Okay. So uh, as I mentioned, we are probably going to have a final exam on January 14th. Yeah. So January, the final exam is January 14th. Okay. I would like you to uh, offer me a schedule. So because uh, the first option, okay, the time will be morning. So from 8, yeah, probably 8:10, around 8:10. Okay. Or do you want it in the afternoon? Really? You don't like in the morning? Because at the afternoon you will be like you can go for holiday, right? Because I believe some of you already bought a ticket for back home, going back home, right? Morning? I mean, is there any schedule in the morning aside from you are maybe lazy to wake up? Because if you finish like around 12, you can go like lunch and then go somewhere, have a holiday, right? Is it okay? And I think your other final is probably before this, right? Before the 14th. Right? Do you have a schedule? Oh, same time? Okay, okay. That's good reason. That's good reason. Okay. So maybe afternoon. Afternoon? Okay. Afternoon. So 1:20, is it okay? 1:20? Okay. Is this schedule okay? 1:20? Check your schedule. What time? The same? Okay, okay. Until what time? Until 3? Okay. Okay. How about uh uh who is having schedule on 8? You, right? Until what time is schedule? 10? 10:20? Afternoon. Okay. Oh, okay. So maybe January 14. How about 13, the day before? It's not okay. Not okay. So so January 14, not okay, right? Not okay because there's some conflict schedule. 13 also no. 13 is not okay. Do you have any other schedule on 13? I mean, any other exam? Any other exam? Any other? Do you have? Or maybe make it 15 on Saturday. Saturday maybe morning at 10. No, right? No, doesn't want, right? Yes. Uh, so 13 is 13 okay? Okay, now what time? 10? 10 okay? No. Afternoon, like our class. Is it okay? Like our class? Okay. Okay. Okay, so 120 January 13. Okay. Okay, so if everyone agrees, so we are settled on the schedule. Okay. Okay. Another thing is uh, the makeup exam. Can you help me, Ria? I think I already arranged. Uh, I think this will be the for GDEP student. This, have, yeah, this is the rest, including IATP and the other department. Yeah, so please check your makeup exam. Okay, please check your score. If there's any complaint, let me know and give me back the paper. Oh, wait, here. Okay, this is the rest. You can check. And yeah, don't worry. Yeah, please check. And after you finish, please return. And maybe if you have any questions, we can discuss first? I think some get good score. A few got unlucky and get less score. And I also already attached all the answer key for your midterm and the makeup one, so you can review if you want. Okay. So yeah, in the I upload on the Google Classroom. You can check the new one. The score? Oh, the first one? Oh, you haven't got? I already mentioned, I think. Okay, later. I think I already told you. Oh, you haven't seen the paper, right? Okay. You can check later. Okay, if you already checked, please return this paper back to me. I haven't put in all through the to the system. If you finish the paper, please put here. Okay. So as a just a small review, this final exam will be include all the integration chapters. Okay, so it starts from chapter 5, 6, 7, and the one that I just uploaded, 8. Just a small part of 8. Just a small part of 8. Okay. If you look up on all these chapters, they are all about integral. Okay. Including chapter 8 is also about the integral. Okay. So chapter 5 start with the definition of integral. Okay. And also, we have this fundamental theorem of calculus, which relate the integrations with the derivative, which means indirectly you need to also need to learn all the chapters, okay, in order to solve problems on the integration part. Okay, so the concept of limit, you need to also remember that limit, the sum of the derivatives, okay, because of the fundamental theorem of calculus. Okay, and then some techniques. First techniques you learn here is the use substitutions method, and then you learn about the applications, okay, applications on chapter 6, which we will have a quiz later. Okay, this will include the area between curves, okay, the volume. We have two methods: volume, the disk, right, and shell. And we also have the average value and the mean value theorem. Okay. And chapter 7, we have several techniques, okay, techniques of integrals. This will be start with the uh, integration by parts, okay, the trigonometric integrals, the trigonometric substitution, partial fraction, and improper integral. There are several chapters in chapter 7 that I don't include. Uh, so, some of them are the approximations. Okay, I will not include the approximation, like the sum rules, trapezoidal, midpoint. I will skip that. So technique, um, as long as you can identify the functions in the integral, I think you don't need to really mentioning which part is it. As long as you know to identify and then resolve the problem, you don't need to know the name of the techniques. Okay. As long as you know and you know the definitions, that's okay. That's okay. Okay. So that's the technique of integrations, chapter 7. Uh, chapter 8 is arc length and area or surface area. Okay. Surface area of revolution. Okay. Okay. Now let me just start with some concept. Okay. A little bit on chapter 8, okay, and then you can review the whole concept on the video that I already upload. Okay. So the concept on chapter 8. Let me start with the okay, let me start just a quick review on the arc length. Okay, the full video you can watch later. Let's just say we have the curve. Okay, we have the curve. Let's say we have a curve f of x, and we have evaluation on from A to B. In the arc length, what we are going to do is we want to measure the length on the curve. Okay? If you read the textbook, and if you have now, you can check your textbook. Your textbook will start to divide the curve. Divide, and they connect all with a straight line. Okay, so they connect with a straight line. Okay, let's say we divide here, here, and here, and let's connect with the straight line. Okay, and with this straight line, okay, we can define each of them a distance, right? And we can have some definitions with the limit and so on and so forth. We will have some integration. Okay. Now, instead of doing this, like your textbook does, okay, let's just write down just a point here, okay, and let's make a tangent line, okay, and let's imagine this line is really small, okay, it's really small in the curves, okay, it's really small. We name it. The length of the tangent line is dl. Okay, we name it dl. This tangent line, we will have a component dx and dy. Okay. Now, if you look at the connections between the dl, dx, and dy, we will have the Pythagorean, right? Okay. Now we can have let's say I'm switching the place, but let me divide this and multiply this. Okay, I can do this, right? I divide and I multiply with the same dx squared, and then we can factorize this dx squared, right? We can factorize. We can factorize also from the square root, right? Becomes just dx. Okay. And the rest will be 1 plus dy over dx squared. I will put outside here dx. Okay. Okay. Everyone agree? Okay. And then dl is a small part on our curves, right? How about if we evaluate dl on every point from A to B? And we can also approach with the limit. Okay? Let's make a shortcut. Let's make a shortcut. Instead of making a distance from each point, let's just imagine having a short line, dl, on every point, and then we evaluate from A to B, which means we are going to have integration here. Okay? And we have L is integration from A to B of this. And this will be our measurement of the length of the curve. Okay. This is usually how I remember how the arc length measurements. Okay. We can use it from the Pythagorean theorem of the tangent line. We mention the tangent line as the short line dl, and we connect with the dy and dx. We can also write the length in terms of dy. We just have switch the dx and dy, and we can factorize the dy. Same thing we have in the process, and we will have, let's just write this is CD, and this will be 1 plus, now is dx over dy squared, and then dy. What does it mean, these two lengths? Okay, the process is first dy over dx. That will be the derivative, right? So you look for the derivative and then square, okay, and then put into this calculation, and then you integrate. Okay. 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 Let me give you example on the outline. Okay. Find the length of the curve. The curve is okay. So that is the curve, and that will be the interval. Okay. So let me give you a few minutes to check and to try. First, you check the curve, check the derivative, and look on the integral. Okay. And we will have last class on Thursday. Okay, last class on Thursday, this Thursday. Probably I will review most of the sections in chapter 5, 6, 7. Okay, I hope we have time on Thursday. And next Tuesday, I'm offering you a class, but it's optional. You can come or not. It's also a review. It's also a review for next Tuesday. That will be the last class, okay, next Tuesday. But that class is optional. And then later about the chapter 8, I will also upload some exercise and some video to solve some problems, okay, including the other chapter as well. Okay, so maybe Thursday review, next Tuesday also review, and also I will add another video, okay, to help you to understand the whole chapters in our final exam. Okay? Because next semester the problem is still the same, derivative, integral, and also the outline will be also included. So if I didn't give you now, probably it will be a lot of chapters next semester. So I want to have like at least outline, and the surface area will be also in our semester. Okay, so you have at least some background on next semester for the calculus. Okay. Okay. Now first we can maybe write down the curve as we can write this as 3/2 like that. And okay, so to avoid mistake in the calculation. And first we can try to find the dy dx. Okay, and this will be resulted on. Okay, and remember in the formula you need to square this, right? So we can square this. So we will have x4 plus 1/4x minus half, right? 2, 2/4, 2, right? Yeah. Or plus, right? Plus, right? Okay. Oh, minus, sorry. Okay. Oh, I think we can just keep the squared part here because we are going to have the square root. But let me see. Okay. Sorry, let me copy this to the next part. Let me write this is the R plane 1 plus dy over dx squared dx from 0 to 1. So we will have 1 plus, oh, yeah, uh, or we can write the x over 4 plus 1 over x minus half and then plus 1, right? Now this whole, it's become, oh yeah, now this plus half, okay, and then dx. Okay, now usually in a typical curve for the arc length, usually the setup, this setup we can rewrite in terms of, okay, if we can imagine this, okay, we can have this factorization. Okay. So usually in arc length, whenever you have some formulation inside, usually you can take some factors and make it into a squared form, usually in a typical arc length problem. And then because of the square root, we can cancel the square root, okay, with the square. So we can cancel this. So this will be an integration, okay, of, let me put out the half outside, and then the inside will be, and then the x. And then each one we can integrate. I think we can integrate this. This become x3 over 2, 2 over 3, plus 2x half. And we integrate, and we need to multiply by half. And this will result in 4 over 3. Okay. Okay. And because of the arc length, we have learned some part of the chapter 8. The other part is the surface area. Okay, let me go to, okay, let me go just the summary of the surface area. Okay. You can rewatch the review of the surface area, how we can get the formula on the video. But the summary, what I want to share with you is we have at least two types. Okay. The first one, let's say this is our functions. This is y, this is x, and we are going to rotate this function on x-axis. Okay? Rotate about x-axis, and this will result on taking this into a, like similar with the volumes that we had, right? But now what we are going to do is we are going to evaluate the surface, here. Okay. So how we are going to do that? Okay. If you watch the video, we are going to find the surface using this small dl here. Okay. There is some dl here. Okay. And we are going to use the surface area, like if you remember the cone, surface area on the cone. You have some L, the side that has a diagonal length. We can evaluate those, and after some steps of calculations, we get that the surface area is 2 pi. It's actually a radius, okay? And then dl, or sometimes some textbook using ds, but that's still okay. This dl means our L here. Okay, and it's evaluated on from some point, let's say just A and B, from A to B. So what does it mean is the radius is the radius on the disk here, right? The radius here, which means this radius will be our function. Okay, the radius is our function. This dl is the arc length. Okay, so we are going to use the arc length. So this is the arc length, and r will be the function. Okay. In our case here, this length, the height, or the radius is y, right? So we can also write, let's just write dl as that. Okay. Now another perspective is we are going to have the rotations is about the y-axis. Okay. So we will have, this will be our radius now, right? Still we have some dl here, right? And of course, we can write down the formulations as maybe c to d to differentiate from the other one. So this will be 2 pi x and dl. Okay. And how we can evaluate the integrations? Okay. So it will depend on the arc length. It can have dx, it can have dy, okay? And the other part will be adjusted to the arc length. Okay? If you are going to have the dx, then all will be in variable x. Okay. So the first thing you need to do is you need to decide which one is the radius. Okay. And how about and also you need to think about the arc length. Okay. So maybe before start to check the surface area, maybe you can evaluate the arc length first. Okay. You have some setup on the arc length, and then put into the evaluation here. For example, if it is on the dx, then the surface will be 2 pi, let's say function of x, and then you have the setup for the arc length, maybe 1 plus, maybe this is dy over dx, and then squared, and then dx. Or maybe if you feel it's too big to write here, maybe you can write as the y prime or f prime x, and then squared. This is also the same, similar writing. Okay. If you want to change into a function of y, you can also change to y, but you need to also change all in terms of y. Okay. Okay. So if the questions, let me just write an example, just a simple example. Find the surface area of the solid revolution formed by rotating y equal x to the power of 4 over interval 0 to 3 about x-axis. So I think this is a typical questions in the surface area. So you have the curve, you have the interval, and you know the rotations about some line. Okay? And this line is x-axis. So you know this surface area, we can write down 2 pi. We have a function of y, and we know at least, okay, we know at least if you have the functions x with the power of 4, at least you will have like that, right? At least, okay? And rotate it on the x-axis, you will have this height, right? You have the radius. And the radius will be the function itself, which is the x with power of 4. So we can write this is x with power of 4, and then write down the formulations of the arc length. So 1 plus, this is 4x cubed squared, and then the x. And to solve this, we can use several ways. One way we can, if we can check with the substitution, if we can, then use substitutions. If we can check with the integration by parts, maybe by parts, or using the trigonometric substitution. Okay. But it seems it's 4 and 6, so I think we can check with the trigonometric substitutions. I think we can check later. Okay. At least you know the first part here. Okay. Okay, I think for the class today, we will stop here. We are going to have more review this Thursday and also next Tuesday. And we will have a quiz, okay, right now, but you can have a break for 5 to 10 minutes if you want. Okay?